Hello and welcome to this section of the Matlab tutor. In this section we're going to begin to learn how to use Matlab to solve algebraic equations. So to do basic algebra and solve equations in algebra that involve simple equations. So there's a couple of ways to do this. The easiest way to do it is to take an example and take it one step at a time. Now, if we're going to solve an equation like this, something simple, you know what the answer to this equation is. X has to be equal to -4. If we want to solve it, the easiest way to do that is to realize what we have is something on the left is equal to 0. So really, we're asking essentially for the roots of this equation. We're trying to find out when this equation crosses the x-axis. That's going to be when this guy is equal to 0. So Matlab has a roots equation, a roots command built in, and what we need to do is basically find the roots of this guy here. So this is x plus 4. Now what you want to do is you want to set up an equation, and you want to tell Matlab what the equation is. Now you don't type in the actual equation like x plus 4 is equal to 0. You just need to define the left-hand side in terms of coefficients. So if I wanted to represent that as a coefficient, it would be 1x plus 4 is equal to 0. So these coefficients really are the only thing that's needed to identify this equation to Matlab. Because remember, we're not doing symbolic math right now. We're still using the numeric capabilities of Matlab. So really all you're going to do is represent this equation by its coefficients on the left-hand side. So 1x, that's why we have the 1 here, plus 4, that's why we have the 4 here. All right, so these are the coefficients of the left-hand side in descending order. So let me go ahead and hit enter, and what's going to happen is we're going to assign this matrix to the word equation. Now then all we have to do is use Matlab's root command and pass it the guy that we just defined. So this is an equation. Matlab knows that when we send something to the roots command, the matrix or the line, the single row matrix that we have is going to be a list of coefficients in descending order. It knows that since there's two coefficients, it has to be 1x plus 4. And it knows that it's set equal to 0 because we're doing the roots of it. And so then it reports the answer is -4, which is exactly what you would expect by moving this over to the other side. So let's get the hang of this with another equation. Let's say we have x squared minus 4 is equal to 0. All right, so you can kind of mentally, I'm choosing easy equations. You mentally move this over, it's going to be a positive 4. You take the square root, so you should have plus or minus 2 as your answer. So we need to represent this on the left-hand side by the coefficient row matrix again. So let's reassign the variable equation. So what do we have here? It was 1x squared minus 4. So we have the 1x squared there plus 0x minus 4 is equal to 0. Now make sure you understand what I'm doing here. What we have here is when you define this guy here, you need to have a spot for everything, for every descending power of x. So it's 1x squared. There are no x's in this equation, so you have 0x. And then the last thing, the constant on the left-hand side, is also wrapped up in there as well. So anytime you have a 0x or anything missing in the descending order of x, you need to make sure and put that in there. This tells Matlab that this is basically a second-degree polynomial. 1x squared plus 0x minus 4 is equal to 0. So let's go ahead and set that up and do the roots of equation. And it says plus or minus 2, which again is exactly what you would expect. You move this over and make it 4, take the square root, you should get plus or minus 2. So let's go to the next guy. The only difference between this one and the last one is we changed the sign here. Now it's x squared plus 4. So what I'm going to do is hit the up arrow key, and I'm going to retrieve the last command. I'm going to do it one more time and retrieve the command before that, just so that I can take this minus sign and basically make it a plus. So that's all that's different between this problem and the last. So I'm going to hit enter. So we've defined the equation in Matlab, or the polynomial we're trying to find the roots of. And then we do the roots of the variable equation that we just defined. Now notice what happens here. We have a complex answer. So again, Matlab has no problem giving you complex answers. Here we have 2i, and the other answer is -2i. And these are conjugates of one another, which is sort of the rules of algebra. You always expect to get these conjugates in pairs like this. And just to make sure that this makes sense, if you move the 4 over here, it should be -4. Take the square root, it'd be plus or minus the square root of -4, and so you're going to get a pair of imaginary answers there. So that's exactly what happens. The only thing you need to make sure of is when you're setting up the coefficients here, you need to make sure and put a 0 anywhere where there is no variable present in your original equation. All right, so let's go down and solve an equation like this. So this is basically the same sort of deal. We have x squared minus 3x plus 9. So let's go and set this up again just for variety. I'll name it Jason, and I'll set up a single row matrix like this, x squared minus 3x. So it's 1x squared minus 3x, and the last part of it was plus 9. And that is the definition of what we're trying to solve here, because here we have x squared, we have a term in x, and we have a constant term, so there's no zeros. Everything is accounted for in our equation. Everything matches up coefficient-wise. So I will go ahead and define that little row matrix there, and I'll do the roots command on what we just defined. And again, we get two answers, which are complex conjugates of one another. The reason we get two answers is because this is a second-degree polynomial. We expect it to cross the x-axis twice. In this case, it's a complex answer. We expect to get two roots. All right, so that's basically how you do it, and you can put more complicated things into Matlab here. Here we have x to the 5th minus 3x to the 4th. So I'll do my last name here. 1x to the 5th. Here we have negative 3x to the 4th, so I'll put a negative 3 there. Now there's no x to the 3rd, so I'm going to have to put a 0 there. But then I'm going to have a 1, and there's no x squareds also, so there's got to be another 0 in there. And then finally there's 1x and then minus 12, so 1 minus 12. And make sure you understand how we arrive at this, because it's really the most important part of everything we're doing here. 1x squared minus 3x to the 4th plus 0x cubed plus 0x squared plus 1x minus 12. So I have to put zeros everywhere where we need that. And then we'll do roots on this variable here. And notice we get 5 answers. The reason we get 5 answers is because it's a 5th order polynomial like this. One of them is real. The other 4 are complex conjugates occurring in pairs, which always is the way algebra works. So far we've been using the roots command. It's pretty powerful. Most of the time you're trying to solve a quick equation, a quick polynomial equation. This is the way you're going to do it. Now, notice that I've set all of these equations up equal to 0, but just to kind of make sure you understand, if you're given an equation like this, where the left-hand side is equal to something on the right-hand side and it's not equal to 0, then what you need to do is mentally sort of move one half of it over to the left-hand side so that it is equal to 0. So for instance, if I wanted to do, equation and set up a matrix again, set up the coefficient matrix, then on the left-hand side it's going to be 1x cubed minus 2x squared. So it's 1x cubed minus 2x squared, like this. And then when we move the x over here, it's going to be negative 1x, so I'll have a negative 1x. And then when I move the negative 2 over, that's going to become a positive 2. So that's going to be a positive 2. And this is how I set up my coefficient matrix for this problem. I'm just trying to let you know that it doesn't have to be equal to 0. You just take what's on one side, you move it over, and then you have the coefficients set up appropriately, and then you just go ahead and solve the problem. So roots of equation. And in this particular case, it's a good example of what not to do. You notice I tried to pass the equation variable inside of brackets. So if you ever do something like that, don't get too worried about it. Just do it the proper way inside of parentheses. And then in this case, we'll get 3 answers. And they're real numbers in this case. The reason we get 3 answers is because we have a 3rd degree or 3rd order polynomial like this. So this is, a really great way to solve quick, simple algebraic equations. A lot of times you're doing a project and inside of a program or something you need to solve an equation. Lots and lots and lots of equations are linear like this, that you need to end up solving quickly, or maybe your coefficients change as you're going through your problem, and your program is adjusting the coefficients and you need to quickly solve them. The roots command is a very quick fast way to do that. The only thing is you have to define the equation. You don't type it out 3x squared plus 2x. You have to give it the coefficients. MATLAB is basically a matrix sort of animal. So it's requiring the input to be in the form of these numbers. And when you think about it, that's all that's needed to represent the equation, are these coefficients. And so the computer can understand what you're asking for and then quickly calculate the answer.